Let's practice solving polynomial equations using factoring. In this first example, x squared plus 35 equals 12x. We saw in the previous lessons that we had to have the equation equal to 0. So that's going to be our first step. Let's get this equation equal to 0. Subtract 12x from both sides. I put the minus 12x term in the middle so that I have my equation written in that standard quadratic equation form. Ax squared plus bx plus c equals 0. I look for a greatest common factor first. Seeing none, we move to the next step, count the number of terms. 1, 2, 3 terms. 3 terms means try the AC method. So A is 1, B is negative 12, C is 35. And notice these are the exact same letters that we use, just capital instead of lowercase. So we need to find two numbers that multiply to be A times C. 1 times 35 is 35. And add to be B, which is negative 12. And we can start with 1. 1 times 35 is 35. But if I want them to add to be negative, I need my factors to be negative. So let's go ahead and make that negative 1 and negative 35. Add them together, we get negative 36. It's too big. 2 will not divide 35. 3 will not divide 35. 4 will not divide 35. But 5 will. So let's take negative 5. 35 divided by negative 5 will give me negative 7. Negative 5 times negative 7 is positive 35. And when I add them together, I get negative 12. So negative 5 and negative 7 are the two numbers that I need that multiply to be 35 and add to be negative 12. Once I find the two numbers, I come back up here to that middle term, negative 12x. We're going to split it into negative 5x minus 7x. Or if you put negative 7x minus 5x, it's totally fine. You're going to end up with the same solution at the end. And then we'll write our x squared and our 35 equals 0, bringing all the rest of the equation down. Essentially, when we factor to solve, I'm ignoring this equals 0 on the right. Once I get it equal 0, I just ignore it. I focus on the left side and I work to factor the left side all the way down completely. And then we worry about the equal 0 part when we get it factored. So let's keep going. X squared minus 5x, let's group the first two, group the last two. X squared minus 5x has an x in common, so I can use the reverse distributive property. X times x will give me x squared. X times negative 5 will give me negative 5x. I'm going to bring that negative sign down in the middle and factor out a negative greatest common factor in the second pair. Negative 7x and 35, 7 in common. Negative 7 times x will give me negative 7x. Negative 7 times negative 5 will give me the positive 35 up above. So negative and a negative will give me this positive that I have. So it's really just important when you factor out a negative here in the middle, when that sign in the middle is negative, then this sign in the second parentheses is going to be opposite whatever the one is above when we factor it out because of multiplying by a negative number on the outside. It takes some practice, so keep practicing with it. Looking at this equation now, I see that x minus 5s are the same in both of these terms, so we're going to factor that out. X minus 5 comes out as one factor, and then x minus 7, those leftover pieces, go in their own parentheses. And we do that because x minus 5 times x minus 5 times negative 7. We're doing that reverse distributive property. Okay, equals to 0. Now my left side is completely factored. Once I get the left side completely factored, meaning the only thing between the main objects on the left side is multiplication, I can take each factor and set each factor equal to 0. X minus 5 equals 0. X minus 7 equals 0. And I'm using that zero factor property. If I multiply two things together and it equals 0, one of them has to equal 0. And then we can solve for x. These are nice linear equations. And I get x equals 5 and x equals 7 that solve my original equation. We can take a moment to check. It's always a good idea to check our work. I'm going to go all the way up to the original x squared plus 35 equals 12x. And I'll first try x equals 5. 5 squared plus 35. Does that equal 12 times 5? 25 plus 35. Does that equal 12 times 5 is 60? And 25 plus 35 is indeed 60. So it works. And we can try 7. X equals 7. 7 squared plus 35. Does that equal 12 times 7? If you need your calculator, no worries. 12 times 7 is 84. 7 squared is 49. And then 49 plus 35. 49 plus 35 does indeed give me 84, and it works, which is what we should expect. I want you to try the next one on your own. X squared minus 15x plus 20 equals negative 30. See if you can come up with the answers. Pause your video. When you return, I'll have the answers, but I'm not going to go through it in detail. You can always check the OneNote and see the different steps that we used. And on this problem, you should get x equals 5 and x equals 10. Let's look at the next one together. X squared minus 36 equals 0. Here we have an equation that already equals 0. So now we work on factoring. Greatest common factor, there's not one. Count the number of terms, 2 terms, x squared and negative 36. I notice that x squared is x squared and 36 is 6 squared. So this is a difference of squares. Difference of squares factors, whatever's in the first spot in my original function being squared, I put that in the first spot in my factors. And then in the second spot, I put that number. One of them's a sum and one's a difference, equal to 0. And I have my factors, x plus 6 times x minus 6. Setting those equal to 0, x plus 6 equals 0, x minus 6 equals 0. I get negative 6 and positive 6 for my answers. Let's look at 32. X squared equals 7x. We need to get it equal to 0. X squared minus 7x. These are not like terms. I don't get to combine them. I have to keep them separate. Look for a greatest common factor. There's an x in both of them. Let's factor that x out. I have it factored. It's completely factored. So now I can set each factor equal to 0 and solve for x. And we have two answers, x equals 0, x equals 7. While we're on this idea of two answers, referring to something that I said earlier in a previous lesson, look at the degrees on the polynomials that we have. The highest power on x is 2. How many solutions do we have? In every case, we have 2 solutions. That is not a coincidence. 2 solutions, degree is 2. Let's pause right here. Since these examples all have my coefficient a on the x squared as 1, we practiced that a lot. We found our 2 answers every time. In the next lesson, we'll look at what if a is not 1. We're going to use the exact same steps we've used before. And then also look at higher degrees for our polynomial equations and see what happens there.